Hey guys, welcome back. For today's video tutorial, I'm gonna have a look over a new sensor that is ITG-3200. Now, we have done a lot of sensors in our previous videos, so I'm gonna introduce to a new digital sensor that is ITG-3200. To gain more knowledge about this sensor, let's have a look over the website controleverything.com and now here search for this particular sensor and let's see what we got here. We got that ITG-3200 is a 16-bit 3-axis MEMS gyro angular rate sensor. So it's a gyrometer in short term, and what we can say about the features as you can see on my screen. Now you can also purchase this sensor from this very site, and I will be moving forward with a lot of options regarding this sensor. Now I'm gonna interface the sensor that is ITG-3200 with a particle photon, and for that I require a particle code. So first of all, go to the resource tab and here comes the particle code sample as you can notice, and you can download the code as zip file from this very site. Now you can also have the opportunity to download the code from github.com, and the repository from where you can have the code is Control Everything Community. Now what do we require is some hardware, some products and the accessories, and let them put together to make some connections for this video. Well, this is here our sensor that is ITG-3200. Now I'm gonna interface the sensor with a particle photon, and for that the question arises how to connect this sensor with a particle photon and a lot other I2C devices, and how to make this connection a lot easier. So the answer is this I2C shield. This is available on the website controleverything.com, and now gently place over the particle photon over the I2C shield and make this connection. Now we need to connect the sensor and the I2C shield. So the binding factor is this, a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this suit for the I2C shield. Hence the connection will look like this. Last but not the least, we have to power up the supply for the Arduino particle photon. Now this is a micro USB cable, and gently place it over the power jack and light it up. So we are done with the connections part. What we require is the particle code so that we can have a look over it and see how it works with the sensor. Now as we done with the connections of the hardware part, now let's see what we got for the code. So for that, first of all, go to and log into github.com, and here search in for the repository that is Control Everything Community, which you are able to see on my screen. Now get over it and here type in the sensor name as you can see, and here it comes ITG-3200, and this is the particle code we are looking forward. Why not we have a look over the instructions for this code, and here it comes. We have to log into our particle photon and set up the device, and the steps are being provided on this web link. So have a closure view of the link so that we can have a generalized view for the instructions. As you can see, introduction is there, getting started, connection over the USB, and a lot more instructions are being provided, and all the steps are elaborately defined. So please do it carefully. Next, we have to download the code or git pull and go to the online ID and copy the code. And the online ID is the build.particle.io link. So let's have a look over it again, and here we go. As you can see, we have the title name, and we can paste the entire code and we can save it from here as you can see. Now last part has verification and flashing of the code of the photon. Now the code output will be displayed at this part, and let's have a look over that. The output will be displayed here after it's being flashed. So this is how it works. Now back to the code. As you can see, the particle code is here. .ino extension file is here. First of all, as you notice in the code, we have included application.h and spark wiring I2C.h header files, and all the functionalities will come by them. Now the address of the sensor is defined here as 0x68. These are some of the variables defined and initialized here. Also in here in the void setup function, as you can notice, we have initialized I2C communication as master and serial communication with the baud rate equal to 9600. Now comes the writing section part. Here we have selected power management register, that is 0x3E, and we have sent the command to power up enable, and the command for that is 0xco1. Now it's good to go, and here we have select the range. It's a gyrometer, so it might be have a range, and as you can see the register is 0x16. Now we have set the full scale range, that is 2000 dps degree per second. Now the command for that is 0x18. So we are done with the connections part, writing part, and now we have the writing section done. Now what we require is to read some data. For that we have selected the data register, that is 0x20, and after that we are requesting and reading 6 bytes of data for gyroscope, that is x, y and z axis, as you can see, and the data is being read, it's being confined to some values, and after that values being stored, we have the conversion for that values, which is according to the data sheet of ITG-3200. Now have a closer look of this, because how it's done. Now after this calculation we need to point out some of the results on the screen. For that we have the output on the dashboard, which is in the form of rotation in x, y and z axis. This is all the raw values we are getting on the string in the form of string on the data sheet and the dashboard. Now this is a very simple code, as you can notice, and you can go through it one by one for further clarifications. Now next what we gonna do is to run this code and see how it works with the sensor. So why not we have a look over that. Now for creating a working environment, what do we require is to copy this entire code. That's the particle code of the sensor ITG-3200. That's a gyrometer, and open up the build terminal. Here build link we have discussed earlier in our video, and here we have to create a new file ITG-3200, and here paste the entire code, and now save the code, and we have the save. And now verify and compile the code, and it's good. Now flash the code. While checking for the flash, we have to check for the magenta flash, which will confirm that the code is good to go and we can have our values. Yeah, that's correct. We have just our magenta flash on the photon, particle photon, and it says that the notification says that the flash is successful. Now what we require is to open up the link for the dashboard, where we can have the output displayed regarding the gyrometric values. As you can see, we have the x, y and z axis of rotation being displayed. The values are there. It's almost stable because there is no motion, no rotation regarding the sensor. When I try to rotate the sensor, you can see the change in the values regarding 3 perpendicular axes of rotation, that is x, y and z. Yeah, that's correct. As you can notice, yeah, it's keep on changing as I keep on rotating. So this is how the sensor works along with this particle code. Now what we require is to see the benefits and the features, and for the reason why we use this sensor in a lot of applications. Let's watch it. So till now we have seen the explanation of the code, working and connections part of this particular sensor. So the ITG-3200 is the world's first single chip digital output 3-axis MEMS gyro IC optimized for gaming, 3D mice and 3D remote control applications. The part features enhanced bias and sensitivity, temperature stability, reducing the need for user calibrations. Low frequency noise is lower than previous generation device, simplifying application development and making for more responsive remote controls. Due to these wide features, it's applicable in a lot of applications like motion-enabled game controllers, motion-based portable gaming, 3D mice and 3D remote controls, no-touch UI, health and sports monitoring, and a lot more. This sensor can be purchased from the website controleverything.com, and you can get the code from the resource tab, and from there you can download it. You can also get the code from GitHub repository, that is Control Everything Community. So as we are done with all the requirements for this particular sensor ITG-3200, I just would like to make it clear that in case if you are in a kind of thought that you are not able to understand any part of this video, any section, you can put your queries on the controleverything.com and put your comments on the community page of this particular website. Now For blogs and articles which are relevant to this video, you can blog or post me on instructables.com. And also, if you have interested or want more video tutorials like this, you can subscribe our YouTube channel. So I hope you enjoyed this video and have yourself a good one. Thanks a lot for watching.